Hello everyone, welcome back to the linear algebra series. In today's video, I'm going to be teaching you all determinant of matrices. Today's video will cover a 2 into 2 matrix and a 3 into 3 matrix. So let's get started with how to find the determinant of a 2 into 2 matrix. So if we have matrix A, and that's A, B, C, and D, the determinant of A, or det A, it can also be written as this symbol right here. That is AD minus BC. So this is a pretty straightforward topic. So now, let's apply this into a question. So the determinant of A would be equal to A times D, which is 3 times 6. So 3 times 6 minus BC, which is 8 times 4. So 3 times 6 minus 8 times 4. So the determinant of A is equal to negative 14. So this is it for 2 into 2 matrices. But it does get more complex when we start learning 3 into 3 matrices. But I'm going to break it down for you, so make sure you stick around until the end of the video. So now, let's start with 3 into 3 matrices and look at how we can go about solving these. So for 3 into 3 matrices, there's a general form we have to memorize. So it's E and then the determinant of I, L, J, and M subtracted by F times the determinant of H, K, J, and M plus G times the determinant of H, K, I, and L. So this is the general form for the determinant of a 3 into 3 matrix. So if you're wondering what these letters are, I'm just referencing it from this matrix above. So this position would be E, this position would be H, and so on. So that's how I got this general form. So now let's look at how we can apply this into a problem. So we have this matrix B right here, and we have these numbers right here, right? So let's first find the ones inside this determinant. If we find these, it'll be easy just to multiply and then subtract and add. So let's first find I, J, L, and M. So this right here is this section. So what is the determinant of I, J, L, and M? That is 4, 5, 0, and 6. Because we can clearly see that I is the term right here. That is equal to 4. J is the term right here. That is equal to 5, and so on. So we have to find the determinant of 4, 5, 0, and 6. So let's multiply 4 and 6. So 4 times 6 minus 5 times 0. Since we have the determinant symbol right here, we're finding the determinant of these four values. So the value is 24. So that's how easy it is. So now, what we have to do is we have to find the determinant of the second part. The second part is H, J, K, and M. Let's go about doing that. So H, J, K, and M. So the values would be 0, 5, 1, and 6. 0, 5, 1, and 6. So why is that? It's because H right here is equal to this H, and H is 0. And then J, as we saw last time, that is 5. So 0, 5, and then so on. We just plug in whatever the values are from the question we have. So let's find the determinant of this. So it would be 0 times 6 minus 5 times 1. That's just negative 5. So we have our second part, which is this right here. So we have this part right here. Now let's move on to our final part, which is h, I, k, and l, and let's find the determinant of that. So the determinant of h, I, k, and l. So that is a really simple process as we just have to continue what we've been doing. So let's look at what h is. We already saw it last time. That was 0, 4, 1, and 0. So that's just our basic pattern on how we can use our general form. This is what I'd like to call the general form of a 3 into 3 matrix with the question. So we just compare them and then plug in the values. That's how easy it is. So now let's find the determinant of this. So 0 times 0 minus 4 times 1, which is 0 minus 4, that's negative 4. And then finally, let's do one last step where we have to compute the determinant of b. So that b would be equal to, let's go back to the expression which we found earlier. So it was e times this minus f times that. So let's look at what e is. We can see right here that e is the first term. So e is 1. So we do 1 times the value of the determinant of I, j, l, and m. And that value is 24. So we'd get 1 times 24 minus, as we have the negative right here, minus f. Let's look at what f is. F is the second term in the first row, which is 2. So it would be minus 2 times the determinant of h, j, k, and m. The determinant of h, j, k, and m is negative 5. So 1 times 24 minus 2 times negative 5 plus, because there's a plus in the general form, if we go back, right here there's a plus, and then g times this determinant right here. So let's look at what g is. Our value of g is the third term in the first row, which is 3. So it would be plus 3 times negative 4, because negative 4 is the value we have right here. So that's how we've made our expression, and that's how easy it is. Finally, our last step is just to evaluate this expression, and that would give us 24 plus 10 minus 12, which is 22. So that's how easy it is to compute the determinant of b. So that's it for today's video. In today's video, let's look at what we've done today. So, in today's video, I discussed 2 into 2 matrices. 2 into 2 matrices. I explained how to find the determinant of them. And that was really simple. You just multiply diagonals and then subtract it from the product of the other diagonal. And then I also explained the general form of the 3 into 3 matrix. I hope you all enjoyed today's video, and please consider liking and subscribing as it helps me out a ton, and I'll definitely be uploading more videos like this until I complete the linear algebra course. Thank you.